Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
When working with agents in the support center via online chat, your organization's customers often share pictures of their documents with personally identifiable information, PII. Your leadership team is concerned that this PII is being stored as part of the regular chat logs, which are reviewed by internal or external analysts for customer service trends. You want to resolve this concern while still maintaining data utility. What should you do? The options are: Option A, use Cloud Key Management Service to encrypt PII shared by customers before storing it for analysis. Option B, use Object Lifecycle Management to make sure that all chat records containing PII are discarded and not saved for analysis. Option C, use the image inspection and redaction actions of the DLP API to redact PII from the images before storing them for analysis. Option D, use the generalization and bucketing actions of the DLP API solution to redact PII from the texts before storing them for analysis.
To arrive at the correct answer, we focus on the keywords, pictures of their documents, personally identifiable information, PII, maintaining data utility.
The correct answer is option C. Use the image inspection and redaction actions of the DLP API to redact PII from the images before storing them for analysis.
Why is this correct? C. The Cloud DLP API provides specific actions for inspecting and redacting sensitive data directly from images. This removes the PII while preserving the non-sensitive parts of the pictures, successfully maintaining data utility for analysts. Why are the others incorrect? A. Encrypting the PII does not resolve the issue effectively. It either prevents analysts from viewing the necessary context or exposes the PII if they have the decryption key, failing the data utility requirement. B. Discarding the chat records entirely destroys the data, which directly violates the requirement to maintain data utility for customer service trend analysis. D. The scenario explicitly specifies that customers share pictures. Text-based generalization and bucketing do not address the PII embedded within image files.
A business unit at a multinational corporation signs up for GCP and starts moving workloads into GCP. The business unit creates a cloud identity domain with an organizational resource that has hundreds of projects. Your team becomes aware of this and wants to take over managing permissions and auditing the domain resources. Which type of access should your team grant to meet this requirement? The options are: Option A, Organization Administrator. Option B, Security Reviewer. Option C, Organization Role Administrator. Option D, Organization Policy Administrator.
To arrive at the correct answer, we focus on the keywords, managing permissions, auditing the domain resources.
The correct answer is option A, Organization Administrator.
Why is this correct? A. The Organization Administrator role provides central control, granting the ability to manage IAM permissions, and view all resources, audit the domain resources, across the entire organization. Why are the others incorrect? B. The Security Reviewer role grants read-only access for auditing purposes, but lacks the necessary permissions to manage access or assign IAM policies. C. The Organization Role Administrator role only permits the creation and management of custom roles at the organization level. It does not allow managing permissions or auditing resources. D. The Organization Policy Administrator role only allows the management of organization policies, constraints, and does not grant the ability to manage IAM permissions or audit domain resources.
You are working with Protected Health Information, PHI, for an electronic health record system. The privacy officer is concerned that sensitive data is stored in the analytics system. You are tasked with anonymizing the sensitive data in a way that is not reversible. Also, the anonymized data should not preserve the character set and length. Which Google Cloud solution should you use? The options are: Option A, Cloud Data Loss Prevention with Deterministic Encryption using AES-SIV. Option B, Cloud Data Loss Prevention with Format Preserving Encryption. Option C, Cloud Data Loss Prevention with Cryptographic Hashing. Option D, Cloud Data Loss Prevention with Cloud Key Management Service Wrapped Cryptographic Keys.
To arrive at the correct answer, we focus on the keywords: anonymizing the sensitive data in a way that is not reversible. Anonymized data should not preserve the character set and length.
The correct answer is option C, Cloud Data Loss Prevention with Cryptographic Hashing.
Why is this correct? C. Cryptographic hashing is a one-way function, ensuring the process is not reversible. Additionally, it outputs a fixed-size hash that does not preserve the original character set and length, perfectly meeting all specified requirements. Why are the others incorrect? A. Deterministic encryption using AES-SIV is a reversible process because the data can be decrypted with the correct key, violating the requirement that anonymization must not be reversible. B. Format preserving encryption is explicitly designed to preserve the original character set and length. It is also reversible, thereby violating all the key requirements of the scenario. D. Using Cloud KMS wrapped cryptographic keys involves encrypting the data, which is a reversible process. This violates the core requirement that the anonymization must not be reversible.
You will create a new service account that should be able to list the compute engine instances in the project. You want to follow Google recommended practices. What should you do? The options are: Option A, create an instance template and allow the service account read-only access for the compute engine access scope. Option B, create a custom role with the permission compute.instances.list and grant the service account this role. Option C, give the service account the role of compute viewer and use the new service account for all instances. Option D, give the service account the role of project viewer and use the new service account for all instances.
To arrive at the correct answer, we focus on the keywords: create a new service account, list the compute engine instances, Google recommended practices.
The correct answer is option B, create a custom role with the permission compute.instances.list and grant the service account this role.
Why is this correct? B. Google recommended practice dictates the principle of least privilege. Creating a custom role with only the specific necessary permission, compute.instances.list, prevents over-provisioning. Why are the others incorrect? A. Access scopes are a legacy authorization method for instances. IAM roles should be used instead for fine-grained access control. C. The compute viewer role grants broad read access to all compute engine resources, violating the principle of least privilege for this specific task. D. The project viewer role grants read access to all resources across the entire project, which drastically violates the principle of least privilege.
An organization is evaluating the use of Google Cloud Platform, GCP, for certain IT workloads. A well-established directory service is used to manage user identities and lifecycle management. This directory service must continue for the organization to use as the source of truth directory for identities. Which solution meets the organization's requirements? The options are: Option A, Google Cloud Directory Sync, GCDS. Option B, Cloud Identity. Option C, Security Assertion Markup Language, SAML. Option D, pub/sub.
To arrive at the correct answer, we focus on the keywords: well-established directory service, manage user identities, source of truth.
The correct answer is option A, Google Cloud Directory Sync, GCDS.
Why is this correct? A. Google Cloud Directory Sync, GCDS, synchronizes users in groups from an existing external directory, the source of truth, to cloud identity or Google Workspace, perfectly meeting the lifecycle management requirement. Why are the others incorrect? B. Cloud Identity is the destination identity platform on GCP, not the synchronization mechanism that allows keeping an external directory service as the source of truth. C. Security Assertion Markup Language (SAML) is an authentication protocol used for single sign-on (SSO), not a directory synchronization tool for managing identity lifecycles. D. Pub/Sub is an asynchronous messaging service, entirely unrelated to identity management, directory services, or user lifecycle synchronization.
Your company requires the security and network engineering teams to identify all network anomalies and be able to capture payloads within VPCs. Which method should you use? The options are: Option A, define an organization policy constraint. Option B, configure packet mirroring policies. Option C, enable VPC flow logs on the subnet. Option D, monitor and analyze cloud audit logs.
To arrive at the correct answer, we focus on the keywords, identify all network anomalies, capture payloads within VPCs.
The correct answer is option B, configure packet mirroring policies.
Why is this correct? B. Packet mirroring clones network traffic, including both headers and actual packet payloads, and forwards it to an internal load balancer for deep packet inspection and network anomaly detection. Why are the others incorrect? A. Organization policy constraints are used to enforce centralized governance and restrictions on cloud resource configurations, not for monitoring network traffic or capturing payloads. C. VPC flow logs capture only network telemetry and flow metadata, such as IP addresses, ports, and protocols, but they do not capture the actual packet payloads. D. Cloud audit logs track administrative actions and data access events across Google Cloud resources, but they do not provide visibility into VPC network traffic or packet payloads.
You are creating a new infrastructure CI/CD pipeline to deploy hundreds of ephemeral projects in your Google Cloud organization to enable your users to interact with Google Cloud. You want to restrict the use of the default networks in your organization while following Google recommended best practices. What should you do? The options are: Option A, enable the constraints/compute.skip default network creation organization policy constraint at the organization level. Option B, create a cron job to trigger a daily cloud function to automatically delete all default networks for each project. Option C, grant your users the IAM owner role at the organization level. Create a VPC Service Controls perimeter around the project that restricts the compute.googleapis.com API. Option D, only allow your users to use your CI/CD pipeline with a predefined set of infrastructure templates they can deploy to skip the creation of the default networks.
To arrive at the correct answer, we focus on the keywords, deploy hundreds of ephemeral projects, organization, restrict the use of the default networks, Google recommended best practices.
The correct answer is option A, enable the constraints/compute.skip default network creation organization policy constraint at the organization level.
Why is this correct? A. Enabling the constraints/compute.skip default network creation organization policy constraint prevents the automatic creation of default VPC networks in new projects, which aligns with Google recommended best practices for security and centralized network management at the organization level. Why are the others incorrect? B. Deleting networks via a daily cron job is inefficient and leaves a vulnerability window where default networks exist until the job runs. It is not a proactive, recommended best practice for organizational security. C. Granting the IAM owner role at the organization level violates the principle of least privilege. Additionally, restricting the Compute Engine API entirely via VPC Service Controls breaks the ability to provision compute resources. Why are the others incorrect? D. Relying solely on predefined templates does not prevent users from manually creating projects with default networks outside the pipeline if they have permissions. Organization policies offer enforced, preventive guardrails instead of relying on templates.
You run a web application on top of Cloud Run that is exposed to the internet with an application load balancer. You want to ensure that only privileged users from your organization can access the application. The proposed solution must support browser access with single sign-on. What should you do? The options are: Option A, change Cloud Run configuration to require authentication. Assign the role of Cloud Run invoker to the group of privileged users. Option B, create a group of privileged users in Cloud Identity. Assign the role of Cloud Run user to the group directly on the Cloud Run service. Option C, change the ingress control configuration of Cloud Run to internal and create firewall rules to allow only access from known IP addresses. Option D, activate Identity-Aware Proxy, IAP, on the application load balancer backend. Assign the role of IAP secured web app user to the group of privileged users.
To arrive at the correct answer, we focus on the keywords: Cloud Run, exposed to the internet with an application load balancer, only privileged users from your organization can access, browser access with single sign-on.
The correct answer is option D, activate Identity-Aware Proxy, IAP, on the application load balancer backend. Assign the role of IAP secured web app user to the group of privileged users.
Why is this correct? D. IAP integrates with application load balancers to provide seamless identity-based access control and single sign-on (SSO) for browser-based web applications, fulfilling all requirements. Why are the others incorrect? A. The Cloud Run invoker role requires attaching an identity token to programmatic API requests, which does not support seamless browser access with SSO. B. The Cloud Run user role is an administrative role used for managing and viewing the service, not for invoking or accessing the hosted web application. C. Relying on internal ingress and IP-based firewall rules does not meet the requirement for user-level identity authentication or single sign-on.
You have placed several compute engine instances in a private subnet. You want to allow these instances to access Google Cloud services, like cloud storage, without traversing the internet. What should you do? The options are: Option A, enable private Google access for the private subnet. Option B, configure Private Service Connect for the private subnet's virtual private cloud, VPC, and allocate an IP range for the compute engine instances. Option C, reserve and assign static external IP addresses for the compute engine instances. Option D, create a Cloud NAT gateway for the region where the private subnet is configured.
To arrive at the correct answer, we focus on the keywords: private subnet, access Google Cloud services, without traversing the internet.
The correct answer is option A, enable private Google access for the private subnet.
Why is this correct? A. Private Google access enables VMs in a private subnet with only internal IP addresses to reach the external IP addresses of Google APIs and services, such as cloud storage, without traversing the public internet. Why are the others incorrect? B. Private Service Connect connects to specific published services across VPCs. While it can connect to Google APIs, private Google access is the standard, simpler solution for a private subnet to access Google Cloud services. C. Assigning static external IP addresses would route traffic over the public internet, which directly violates the requirement to access the services without traversing the internet. D. Cloud NAT provides general outbound internet access for instances without external IPs. The requirement is specifically to access Google services without traversing the internet, which private Google access achieves natively.
Your Google Cloud environment has one organization node, one folder named Apps, and several projects within that folder. The organizational node enforces the constraints/IAM.allowed policy member domains organization policy, which allows members from the terraearth.com organization. The apps folder enforces the constraints/IAM.allowed policy member domains organization policy, which allows members from the flowlogistic.com organization. It also has the inherit from parent, false property. You attempt to grant access to a project in the apps folder to the user, email protected. What is the result of your action and why? The options are: Option A, the action succeeds because members from both organizations, TerraEarth.com or FlowLogistic.com, are allowed on projects in the Apps folder. Option B, the action succeeds and the new member is successfully added to the project's Identity and Access Management (IAM) policy because all policies are inherited by underlying folders and projects. Option C, the action fails because a constraints/IAM.allowed policy member domains organization policy must be defined on the current project to deactivate the constraint temporarily. Option D, the action fails because a constraints/IAM.allowed policy member domains organization policy is in place and only members from the FlowLogistic.com organization are allowed.
To arrive at the correct answer, we focus on the keywords: constraints/IAM.allowed policy member domains, inherit from parent, false.
The correct answer is option D. The action fails because a constraints/IAM.allowed policy member domains organization policy is in place and only members from the FlowLogistic.com organization are allowed.
Why is this correct? D. The folder policy uses inherit from parent, false, which explicitly breaks inheritance and replaces the organization-level policy. Consequently, only members from the FlowLogistic.com domain are permitted within the apps folder, causing the addition of users from other domains to fail. Why are the others incorrect? A. Because the folder policy is explicitly set to not inherit from the parent, the TerraEarth.com domain allowance is overridden. Only FlowLogistic.com members are allowed. B. While organization policies are inherited by default, the explicit inherit from parent, false configuration on the apps folder intentionally breaks the inheritance from the organization node. Why are the others incorrect? C. The failure is not caused by the lack of a temporary deactivation policy on the project. It fails because the active, overriding folder-level policy restricts access exclusively to FlowLogistic.com members.
Your customer has an on-premises public key infrastructure, PKI, with a certificate authority, CA. You need to issue certificates for many HTTP load balancer frontends. The on-premises PKI should be minimally affected due to many manual processes, and the solution needs to scale. What should you do? The options are: Option A, use Certificate Manager to issue Google-managed public certificates and configure it at HTTP the load balancers in your infrastructure as code, IAC. Option B, use a subordinate CA in the Google Certificate Authority service from the on-premises PKI system to issue certificates for the load balancers. Option C, use Certificate Manager to import certificates issued from on-premises PKI and for the frontends. Leverage the cloud tool for importing. Option D, use the web applications with PKCS12 certificates issued from subordinate CA based on OpenSSL on-premises. Use the cloud tool for importing. Use the external TCP/UDP network load balancer instead of an external HTTP load balancer.
To arrive at the correct answer, we focus on the keywords: on-premises public key infrastructure, PKI, certificate authority, CA, issue certificates for many HTTP load balancer frontends, on-premises PKI should be minimally affected, solution needs to scale.
Correct answer is option B. Use a subordinate CA in the Google Certificate Authority service from the on-premises PKI system to issue certificates for the load balancers.
Why is this correct? B. Creating a subordinate CA in Google Cloud CAS anchors trust to the on-premises PKI while offloading the issuance of numerous certificates to a scalable, automated cloud service, satisfying all requirements without overloading manual on-premises processes. Why are the others incorrect? A. Google-managed public certificates do not integrate with the customer's existing on-premises PKI, failing to leverage their internal trust hierarchy. C. Importing certificates issued by the on-premises PKI relies on the existing manual processes, failing the requirement to minimally affect the on-premises PKI and scale. D. This approach relies on an on-premises OpenSSL subordinate CA, affecting the on-premises environment, and incorrectly suggests using a TCP/UDP network load balancer instead of the requested HTTP load balancer.
Your organization wants full control of the keys used to encrypt data at rest in their Google Cloud environments. Keys must be generated and stored outside of Google and integrate with many Google services, including BigQuery. What should you do? The options are: Option A, use customer-supplied encryption keys, CSEK, with keys generated on trusted external systems. Provide the raw CSEK as part of the API call. Option B, create a KMS key that is stored on a Google-managed FIPS 140-2 Level 3 Hardware Security Module, HSM. Manage the Identity and Access Management, IAM, permission settings, and set up the key rotation period. Option C, use Cloud External Key Management, EKM, that integrates with an external Hardware Security Module, HSM, system from supported vendors. Option D, create a Cloud Key Management Service, KMS, key with imported key material. Wrap the key for protection during import. Import the key generated on a trusted system in Cloud KMS.
To arrive at the correct answer, we focus on the keywords: full control of the keys, generated and stored outside of Google, integrate with many Google services including BigQuery.
The correct answer is option C, use Cloud External Key Management, EKM, that integrates with an external hardware security module, HSM, system from supported vendors.
Why is this correct? C. Cloud External Key Management, EKM, allows you to use keys managed in an external key management system, providing full control of keys generated and stored outside Google while maintaining seamless integration with supported Google Cloud services like BigQuery. Why are the others incorrect? A. Customer-supplied encryption keys, CSEK, are not supported by many Google Cloud services, specifically BigQuery, failing the requirement for broad integration. B. Creating a key on a Google-managed HSM means the key is generated and stored inside Google, violating the requirement to store keys outside of Google. D. Importing key material into Cloud KMS means the key will reside and be stored inside Google Cloud, which directly violates the requirement to store keys outside of Google.
An organization is starting to move its infrastructure from its on-premises environment to Google Cloud Platform, GCP. The first step the organization wants to take is to migrate its current data backup and disaster recovery solutions to GCP for later analysis. The organization's production environment will remain on premises for an indefinite time. The organization wants a scalable and cost-efficient solution. Which GCP solution should the organization use? The options are: Option A, BigQuery using a data pipeline job with continuous updates. Option B, cloud storage using a scheduled task and SUDL. Option C, compute engine virtual machines using persistent disk. Option D, cloud data store using regularly scheduled batch upload jobs.
To arrive at the correct answer, we focus on the keywords: data backup and disaster recovery, scalable and cost-efficient.
The correct answer is option B, cloud storage using a scheduled task and SUDL.
Why is this correct? B. Cloud storage provides highly scalable and cost-effective object storage, which is ideal for storing backups and disaster recovery files. Using SUDL with scheduled tasks is a standard, efficient method for migrating this data from on-premises. Why are the others incorrect? A. BigQuery is a data warehouse designed for analytics, making it an inappropriate and expensive choice for general-purpose raw backup and disaster recovery storage. C. Compute engine virtual machines with persistent disks are significantly more expensive and require more management overhead for storing backups compared to cloud storage. D. A cloud data store is a NoSQL document database meant for application data and is not suited for storing large-scale backup files or disaster recovery images.
You want data on compute engine disks to be encrypted at rest with keys managed by Cloud Key Management Service, KMS. Cloud Identity and Access Management, IAM. Permissions to these keys must be managed in a grouped way because the permissions should be the same for all keys. What should you do? The options are: Option A, create a single keyring for all persistent disks and all keys in this keyring. Manage the IAM permissions at the key level. Option B, create a single keyring for all persistent disks and all keys in this keyring. Manage the IAM permissions at the keyring level. Option C, create a keyring per persistent disk, with each keyring containing a single key. Manage the IAM permissions at the key level. Option D, create a keyring per persistent disk, with each keyring containing a single key. Manage the IAM permissions at the keyring level.
To arrive at the correct answer, we focus on the keywords: compute engine disks, encrypted at rest, keys managed by Cloud Key Management Service, KMS, Cloud Identity and Access Management, IAM, permissions, managed in a grouped way. Permissions should be the same for all keys.
The correct answer is option B, create a single keyring for all persistent disks and all keys in this keyring. Manage the IAM permissions at the keyring level.
Why is this correct? B. Granting IAM permissions at the keyring level automatically applies those permissions to all keys within the ring, perfectly meeting the requirement to manage permissions in a grouped way. Why are the others incorrect? A. Managing permissions at the key level requires individual policy configuration for each key, violating the requirement for grouped management. C. Creating a keyring per disk and managing at the key level does not group permissions and introduces significant administrative overhead. D. While managing at the keyring level groups keys within a ring, having a keyring per disk still requires configuring permissions on every individual keyring.
Your team wants to make sure compute engine instances running in your production project do not have public IP addresses. The front-end application compute engine instances will require public IPs. The product engineers have the editor role to modify resources. Your team wants to enforce this requirement. How should your team meet these requirements? The options are: Option A, enable private access on the VPC network in the production project. Option B, remove the editor role and grant the compute admin IAM role to the engineers. Option C, set up an organization policy to only permit public IPs for the front-end compute engine instances. Option D, set up a VPC network with two subnets, one with public IPs and one without public IPs.
To arrive at the correct answer, we focus on the keywords: do not have public IP addresses, require public IPs, editor role, enforce this requirement.
The correct answer is option C, set up an organization policy to only permit public IPs for the front-end compute engine instances.
Why is this correct? C. Organization policies allow centralized enforcement over which VM instances can have external IPs using the compute.vm external IP access constraint, effectively overriding resource-level permissions like the editor role. Why are the others incorrect? A. Private Google access allows VMs with internal IPs to reach Google APIs, but does not prevent users with editor roles from assigning public IPs to instances. B. Granting the compute admin role does not restrict public IP assignment, as this role still possesses the necessary permissions to attach external IP addresses. D. Subnets in GCP do not inherently prevent public IP assignment. Placing a VM in a specific subnet will not stop an editor from attaching a public IP.